lesson 4, distribution of multiple samples. We're on page 458. You want to have a highlighter and calculator. So we've learned the importance of choosing a sample randomly so that the sample represents a population. If a sample is chosen with good methods, it's still possible for the data from the sample to be different than the data from the entire population. So if that's possible, how can we ever make any decisions from data sample? And this is a question we'll be answering for the rest of the unit. So our first exercise, what I have here is a bag of colored beans. Some of the beans are red, some of them are tan. If I was with you in class, you would each have a bag of beans like this, and you would select 20 beans from the bag. Each group of beans is 40% red. That means I can tell you that there are 100 beans in this bag, and if 40% is red, there are 40 red beans. So the population proportion of red beans is 0.40, 40 out of 100. This is equivalent to 0.40. So what I'm going to do is I'm going to take 20 beans out of the bag, just randomly. Grab a handful and count out 20. 2, 3, 4, 6, 8, 10, 12, 14. I think I moved that. 15, 16, 17, 18, 19, 20. And from these 20, how many are red? 2, 4, 6. There are 8 red. Double check. 2, 4, 6, 8, 10, 12. So the proportion of red beans out of this 20 is 8 out of 20, which is equivalent to 8 divided by 20. That's 40.40. I'll place the beans back in the bag, and I'll do this a second time, and then I'll pause the video and I'll do it several more times so that we have several samples of 20 beans pulled from the bag. And the proportion of red beans. All right, 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. One more bean, there we go. All right, 2, 4, 6, 8. So I've counted 10 red beans. Whoops, maybe not. Double check. 2, 4, 6, 8, 10 red, and that means there should be 10 tan. Yes. So this proportion of red beans out of this sample of 20 was 10 out of 20, which is equivalent to 0.50. Okay, so again, to save time, I'm going to pause the video and I'm going to repeat this process several times, and then I will come back and we will make a, I will put the proportion of red beans that I found on this sampling distribution of sample proportions. So what I did is I did that 33 more times, so I have a total of 35 samples, and the sample proportions, I went and placed them on the dot plot here. So if you would take a minute for 0.15, put 1 dot, 0.25, 1 dot, 0.30, 2 dots, 0.354, 0.40, 5 dots. I'm just writing the totals up above. 4, 5, 5, 5, 0, 7, 6, 3 for 0.60, and 1 for 0.65. Again, this is known as the sampling distribution of sample proportion. Our sample size is 20. What I want to do is I want to note the spread. The spread is from 0.15 to 0.65. Now, before I find the mean and standard deviation using the calculator, describe the shape of this distribution. Well, it's somewhat mound-shaped. The smallest sample proportion observed was 0.15. The largest, 0.65. What sample proportion occurred most often was the 0.50 that occurred 7 times. Now, using the calculator, I'm going to find the mean and standard deviation, rounding to the nearest hundredth. So to save time, I have this in my calculator already. L1 is the proportion and L2 is the frequency. Stat, calc, we want one variable, statistics. We need the frequency list in there, so I'll paste in L2, not paste it, but type it in. So second 2 is L2. Okay, that's in there. Now calculate. So our mean is to the nearest 100.45. And our standard deviation, Sx, is 0.11. How does the mean of the sampling distribution compare with the population proportion of 0.40? Well, 0.45 is close to 0.40. If we were to take another sample of 20 beans, give a range for the proportion that you would expect to occur. What we would expect to occur, this is very important, is considered a 95% confidence interval. Which is the mean plus or minus 2 standard deviations. We would expect 95% confidence interval, which is the mean plus or minus 2 standard deviations. Very, very important. So our mean was 0.45 plus or minus 2 times our standard deviation of 0.11. That's going to give me a high of 0.45 plus 0.22 is 0.67, and 0.45 minus 0.22 is 0.23. So we would expect a proportion between the range of 0.23 to 0.67. What do we think would happen to the sampling distribution if everyone in the class took a sample of 40 beans from their bags instead of 20? All right, to help answer this, what's happened here is a simulation has been run to make this process easier, and we have another distribution of sampling proportions in the form of a dot plot for us. So there are 30 dots here. Let's note the spread. The spread is from 0.30 to 0.55. And this is a sample of 40 beans. Instead of 20. So I'm just going to count. We have 1 there, 1 midway between it. That would be at 0.325. 2, 4, 6. I think that's 7. Okay, so I had paused the video and I had placed the data proportion in L1 and in L2 the frequency. Describing the shape, it's somewhat mound shaped. The smallest proportion is 0.30. The largest 0.55, and the sample proportion that occurred most often, well, we have 0.375 and 0.425. Again, using technology, stat, calc, one variable statistics. I'll have to paste in the frequency list. Second L2. And here our mean is 0.43 and the standard deviation 0.06. Okay, so this mean of 0.43 is close to 0.40. If we were to take another sample of 40 beans, give a range of proportion we would expect to occur. This is our 95% confidence interval. I'm just going to abbreviate CI for confidence interval. It is the mean plus or minus 2 standard deviations, 0.43 plus or minus 2 times 0.06. It gives us a high of 0.55 and a low of 0.31. Could certainly do that on the calculator. 0.43 plus 2 times 0.06. And I put a 5 there, so let me go back and change that to a 2. 0.55, arrow up, grab that, change the plus to a minus, 0.31. So 0.31 to 0.55. As the sample size increased from 20 to 40, what happened to the sampling variability? That is the standard deviation, the sampling variability, the standard deviation. Here was 0.06. Here was 0.11, decreased. The standard deviation decreased. The larger the sample size, the smaller or the narrower the variability. The larger the sample size, the lesser or the smaller the variability. Very important. So if we increase from 40 to 80, the standard deviation would decrease again. The larger the sample size, the smaller, the lesser the variability. And you also see that our spread decreased. With 40 beans, it was 30 to 55, and with 20 beans, it was 15 to 65. Okay, 16 minutes. I'm going to stop there. And now you're going to work on the practice problems. Thank you for your attention.